What's up, everyone? So last week we learned how to solve quadratic equations by factoring and then also by using square roots. This week we're going to combine the two approaches using a technique called completing the square. So hopefully you've printed out your notes that you got from your teacher's webpage, and you're going to follow along with me. So in this video, I'm just going to do the first page, example number 1, and then I'll make separate videos for the other examples on page 2. Okay. All right. So some quadratic equations cannot be solved by factoring. So another method that we use is called completing the square. So the steps of solving a quadratic equation, whose form is, you got a second power term, a first power term, a constant, and it's set equal to 0. Okay. And so we've kind of broken down the steps for you here. 6 steps. I know it seems like a lot, but hopefully I'll make it kind of painless for you. All right. So here's our first quadratic equation: 2x squared plus 20x minus 8. Now I'm actually going to switch these first 2 steps. Okay. You can do it in the order that it's printed on the page, but I'm just going to choose to do it step 2 first. Okay. So let's divide, okay, to make the coefficient of x squared equal to 1. All right. So in other words, I don't really want this to be 2x squared. I just want it to be 1x squared. Okay. So what we'll do is we will divide both sides of our equation, right, both expressions, by 2. All right. So 2 divided by 2 is 1, right? So we get that 1x squared. 20 divided by 2 is 10. So now we've got 10x squared. Negative 8 divided by 2 is negative 4. And then 0 divided by 2 is 0. Okay. So now I've got a much simpler looking quadratic function or quadratic equation. Okay. All right. And now I'll go back and do step 1. I'm going to isolate the constant. Okay. So in other words, I want that constant term, right? That's the term without any variable on it, to be by itself. And so let's move it over to the right-hand side. Okay. So I'm going to add 4 to both sides. Okay. All right. Opposites add up to 0. They cancel each other out. So we're going to end up with x squared plus 10x, no constant term because it's now going to be over here on the right-hand side. All right. So now we get to the actual meat of this technique, which is the completing the square. And so I'm going to approach this kind of from a visual standpoint, or using that area model to hopefully give you a better idea of what's going on. Okay. So I'd like to represent this expression here using the area model. Okay. So let's go ahead and draw our area model, and you will recall that we typically have 4 smaller boxes in there. Okay. All right, and then I'm also going to represent the right expression, right, using the area model as well. Okay, so for now, I'll just draw a big box, same size as this one. I'm just not going to divide it into 4 squares just yet. Okay, so our second power term, we recall, goes in the first box. Okay, our first power term is usually split up among these 2 diagonal boxes. So 10 is an even number. It splits. We can write it as 5x and 5x. Okay. And then we've got this missing piece, right? Because there was no constant here, that's why this box is empty. Okay. So what we have is x squared plus 10x is being represented by these 3 boxes in the area model, right? X squared plus 10x. Okay. But that expression is equal to 4, so in the other area model, okay, I'm going to have the same region being represented by 4, right? So x squared plus 10x is equal to 4. All right, so now we're going to try to start factoring the area model on the left just by thinking about what dimensions we would need, right? So for x squared, that first box, the dimensions would need to be x by x. Okay? For this box, 5x, well, we know x is going to be one dimension, 5 is going to be the other dimension. We can say the same thing about this, right? 5x, so x times 5. All right, so now, what is this, this fourth box down here, right? And this is where the term completing the square comes from, because we're now going to fill in that fourth box because we now know what the dimensions are, right? 5 times 5 means this is going to be 25. So we're going to go ahead and add 25, and that now completes our square. But, you know, with equations, right, the golden rule is whatever you do to one side, you do to the other side. So since we added 25 to complete this square, we would need to add 25 to complete the square on the right. Okay, all right. So that's completing the square from a visual standpoint. Okay, so now what do we have? So the square on the right could be represented as a trinomial, right? X squared plus 10x plus 25, but we can also represent it by its dimensions, right? X plus 5 times x plus 5. So let's write it as factors, right? X plus 5 times x plus 5. Okay. And then our square on the right, well, that could just be represented by the sum of these two regions. 4 and 25 makes 29. All right, now, we know that when you multiply something by itself, right, repeated multiplication can be represented using exponents, okay? So I have x plus 5 repeatedly multiplied, well, twice, right? So I'm going to write that using the second power. So this is going to be x plus 5 quantity squared. Okay, and we still have just the constant 29 on the right-hand side. Okay. So at the beginning of the video, I mentioned how, you know, this technique is going to involve factoring and square roots. So we've done the factoring part, right? The area model leads to factoring, okay? And now we're going to do the square root portion, right? Because our ultimate goal is to get x by itself, okay? So now we're going to have to use inverse operations to isolate x, okay? Well, what operations are happening to x right now? Well, there's addition and there's squaring, okay? So we need to reverse those things. Okay? So yeah, you might have recall from last week, Mrs. Wheelock's video, right? The inverse of squaring is square rooting. So now we're going to take a square root, right, to both expressions. So the square root and the second power wipe each other out, they cancel each other out. So now we just have the expression x plus 5. And then again, if you recall, from Mrs. Wheelock's video last week, when you take a square root of a number, there's actually two square roots. There's a positive and a negative. Okay? And the way we represent that is using the plus or minus sign. So we're going to write plus or minus root 29. Okay. Now, 29 is a prime number, right? It's not factorable. But, you know, let's say this number was 49, right? 49 is a perfect square. You could actually take the square root of that. It'd be plus or minus 7. Okay. But in this case, since 29 is not a perfect square, we're just going to leave it in radical form. Okay. All right. So this technically is two equations kind of condensed into one. I'm going to separate it into two equations. Okay. So we can write it as, let's see, x plus 5 is equal to the positive root of 29. And then we can write x plus 5 is equal to the negative root of 29. Okay. So we're taking this one kind of shorthand equation and separating it into its two individual equations. All right, now we're just one step away from getting the solutions, right? Remember, we want to isolate x. Right now, x is having the addition operation applied to it. So to reverse addition, we need to subtract. So I'm going to subtract 5, the integer 5, from both sides. Okay. So the integers, positive 5 and negative 5, add up to 0. Okay, so we just have x. Okay. And then be careful here, because you cannot actually combine an integer with a radical. Okay. So we're just going to have to write them as separate terms, right? So negative 5 plus the root of 29. Okay. And then we'll do the same thing on this equation. Positive 5 and negative 5 are both integers, and they're opposites, so they add up to 0. Okay, so x is equal to, and then once again, you cannot combine an integer with a radical. So we're going to write these as separate terms. Negative 5 minus the root of 29. And technically speaking, those are our solutions. Okay, they're in radical form, which is, I don't know, for students or in everyday life, it's maybe not the most convenient, but we can use our calculator to estimate these as decimals. Okay. All right, so let me pull this up here. Let's do the first expression, negative 5 plus the root of 29. Okay, it's about 0.385. So x is equal to 0.385, or I should use an approximation symbol. Sorry about that. Okay, so there's one solution. Now keep in mind, you can also leave your solution in radical form. So just showing you two different options. And then for this one here, let's do negative 5 minus the root of 29. And that's negative 10.385. So x is approximately negative 10.385. Okay, so it might look like I'm saying there's 4 solutions, but really there's only just 2. Okay, so we can represent the 2 solutions in radical form, or we can represent the 2 solutions in decimal form. Okay, so what do these 2 numbers represent? Well, they represent the solution to this quadratic equation. Okay, but we can also think about this quadratic equation as a function in the coordinate plane, and then these 2 x values really represent the x-intercepts. And I just want to show that to you real quick. I'm going to switch over to Desmos and show you what that would look like. Okay, here we go. All right, so let's go to Desmos, and I already typed the quadratic function, right? Originally, it was 2x squared plus 20x minus 8, right? That's what we started with. So let me turn it on, and you can see here the parabola. Right, I'll zoom out so you can see all the way down to the vertex. Okay, and then I'll zoom back in. And then let's take a peek at where that parabola crosses the x-axis. So there's one value there, negative 10.385. Sound familiar? And there's the other x-intercept, 0.385. Okay. So that's what we're doing when we're completing the squares. We're trying to find the x-intercepts of that quadratic function. All right. Now, another cool tool that I want to share with you was created by Mr. Weiner. So shout out to him. And I'm going to link this in the description of the video. So he made this pretty cool tool using Excel that helps you solve a quadratic equation by completing the square. Okay. So I'm going to take the example we just did, and then I'll show you how to use Mr. Weiner's tool. Okay. So when you click on the link in the description, right, it's going to open up this Excel file. You may have to click the Enable Editing button. I already did it. It's like somewhere over here in the center of the screen. All right. And then what we want to do is, well, let's just follow these blue clues here, right? Enter the B and C values. Okay. So where in our problem did our equation look like an x squared term plus an x term plus a constant, okay? And so that was actually after the first step, after I divided, right? So we had x squared plus 10x minus 4. So that was our, that was our original, no, that was not our original equation. The original one was 2x squared plus 20x minus 8, but we divided that all by 2. So, and then we got this. All right. So there's going to be this clue here in blue that helps you with each progressive step. And then you'll know you did it right because once you type in a number, the box will turn green. So the first clue is move the constant over, right? So we want to take the constant -4 and move it from the left-hand side to the right-hand side. So we would need to add 4. Okay, so I'll put 4. You see the box turns green. Now, had I written any other number, like 9, right, the box would not turn green because 9 is not the right value. Okay. So let's. Right, the clue changes. Now it says divide b by 2. Okay, so b, here's the structure, right? X squared plus bx plus c. So we want to look for the coefficient in front of the x term, which is 10. Divide that by 2, you get 5. Okay, sign is important, so it's going to be positive 5. Okay, box turns green, so we're good. Okay, square that value. Okay, so 5 squared is 25. Add to both sides. Okay, so we're going to add 25 there, and then we're going to add 25 there. Okay, you can see the boxes are turning green. All right, add up the right side. Okay, 4 and 25 makes 29. Okay, square root both sides. Okay, so here we have that x plus 5 squared, right? Square root reverses squaring. So we would just have the binomial x plus 5. And then 29 is a prime number. It's not a perfect square. And so we're just going to represent it in root form, so plus or minus root 29. Now we've already solved this problem, and we found out there were 2 solutions. Okay, and there will always be 2 solutions when this number is bigger than 0. Okay, which I think is probably going to happen the majority of the time. Okay, if this was 0, then we would have 1 solution, and if this was a negative number, we wouldn't have any solutions. Okay, so I might get into that in more detail in a future video, but just for now, know that if that's a positive number inside the root, we're going to have 2 solutions. All right, so what are the solutions? We're going to write them in radical form. Okay, remember we have plus 5 here, so we're going to have to minus 5 to both sides. So we'll have minus 5 plus or minus the square root of 29. And then here's where we're going to write our answers in decimal form, and we're going to round to 2 decimal places. Okay, I'm just taking a look at my notes because we already did this problem. So I think 0.39 and negative 10.39. And it turns green, so we got it right. All right. So I hope you enjoyed this video. Again, this was only the first page. So I'll either link the videos I make for the other problems, or it'll be like in a playlist, but those will be coming up shortly. All right. Thank you guys so much for watching.